Okay, so I think it's 11 o'clock and it looks like the people coming in has slowed down, so I think I'll get started. So welcome to my talk. I'm Michael Dawson, and today I'm going to be talking to you about Node.js in a Kubernetes world. A little bit about myself before I get started. I'm Michael Dawson. I'm IBM's community lead for Node.js, and what that means is I get to spend a lot of time working in the community. I'm on the technical steering committee and active on a lot of the different working groups and teams. It also means, though, that I get to work with some really good teams within IBM, working to do some cool things like make sure Node.js runs on our platforms, S390, PowerPC, as well as our cloud teams making sure that they're a great place to deploy Node.js, as well as some other things which I'll get into. So just before I get started, a little bit to let you know what I'm going to talk about. I'll start out with IBM's JavaScript involvement and kind of a little bit on our strategy. I'll talk about cloud-native development, some of the key tasks that I think you need to be aware of as a Node.js developer coming to the cloud-native development Kubernetes world. Talk a little bit about separating concerns. You'll see as we go through this, there's a lot of things that, at least from my perspective, I don't necessarily want to have to worry about every time I'm developing an application, and separating those concerns can help. And then finally, I'm going to just touch on some available tools that you might be interested in taking a look at and learning more about. So to start with, IBM's involved in Node.js in a number of different ways. We're, of course, very active in the community. We have 11 core collaborators, 4 people on the technical steering committee, and we really try to invest in the community to make sure Node is a great platform to develop on. As I mentioned before, we work hard to make sure that you get good Node support on our platforms. We also want to make sure that when you deploy to the cloud, either public or private cloud, it's a great environment to deploy those Node applications. We also work on developer enablement, so making sure that when you're developing your applications, you're efficient, and when you deploy to production, you're successful. And then finally, we offer commercial support, so when you're in production, we can help you if you run into problems. Today, I'm really going to be talking about the developer enablement front and some of the work that we're doing on that front to help you be efficient and be successful in production. 2 key things in that aspect are rapid development. So you want to be able to create the first version of your application quickly, as well as it's very important to be able to iterate on those so that you can deliver more and more value incrementally, but not be sort of slowed down by the cycle that it takes you to get through the sort of development test and so forth. And then, of course, it's very important that you're successful in production. And today, that really means likely deploying in Docker and then taking those Docker images and deploying them at scale in a Kubernetes environment. Now, I'm not a Kubernetes expert by a long shot. I'm more the Node developer coming to the cloud native and Kubernetes world, and I just want to give you a little bit of an idea of what I see are the things that you should be aware of and be thinking about when you're developing your applications that will likely be deployed in that environment in the end. So when you think about cloud-native development, one of the things you'll often hear about is 12-factor applications, and you can go read more about the different aspects of that. But it's basically a set of tenets that you want to follow in developing a modern application. Some of them that are specifically relevant to what I want to talk to you today about are keeping development, staging, and production as close as possible. You want to test where you're going to be deploying. Treating logs basically just as streams, and exporting services via ports. So you'll see that some of that comes back through the talk. In terms of the key tasks, I'm going to talk about these things in terms of what, as a new Node.js developer, you need to think about. So one is well, I'm going to have to be building Docker images. So what do I need to know about that? I'm then going to have to deploy those Docker images, both for my own testing and in production. I'm going to need to figure out how I'm going to test them in those environments. And Kubernetes brings with it some key qualities of service that you want to do some work on your application to support. So things like health checking, logs, metrics. And then finally, before I get into tooling, I also want us to think a little bit about upgrades. What happens when I need to upgrade my application? Because that ends up being, as you become more and more successful, a bigger and bigger part of the work that you actually have to do. I just have some references to cloudnativejs.io over here. That's a site where there's some best practices, tools, and techniques for writing applications in JavaScript that are going to be deployed in a cloud-native environment. And I'm going to be touching on some of those tools, so I just have the reference there. So the very basic step is, the first difference is I'm going to likely have to get my Node application into a Docker image. And so what does that mean? Well, luckily, the community actually builds some base Docker images that already include Node for you. These are done by one of the teams, and fairly quickly after a Node release, you'll see that there's new Docker images published to Docker Hub. They're official images. They're cross-platform. They support, x86, S390, Power, so you can use them on any of those platforms. And they're named based on the name. So for example, there's one for 12.13.1. And they bundle a Node.js binary into a base operating system. There's a few variants. There's the base one, which is just Node : that takes a Debian image and bundles Node into it, with most of the things that you're going to need to build and run your Node.js application, so the compilers and so forth. The Node Slim version is the minimal package that you're going to need to run. So it's a smaller image, but may not have everything that you need to, say, build your application if you have native modules in it. And then finally, there's an Alpine version, which is if you're really focused on container size. Alpine is a distribution that has a smaller footprint, and so we bundle Node into there. A little bit of a caveat that uses a different glibc, or like the C base library, and so it's maybe not tested quite as well in the overall Node infra as the others. There are, of course, others in addition to the official repositories. So for example, Red Hat ships a couple of UBI images. And those are images that you can use because they're open source. But if you want to get support, you can actually run them in a way where you can actually be supported as well. So once you have your Docker image, or once you have your base image that you're going to build on top of, how do you actually get your application into the image? What you're going to need to use is something called a Docker file. And in the picture here, I have the very simplest Docker file, which just says from this base image. So that's the image I'm going to use from GitHub, the one that the community puts out. It's telling you what port it's going to use. That's informational. And in this case, I just copy a server.js into the container at the root directory. And then you give it the command, which says, OK, start up the server, Node.js server. Very simple. It does get a lot more complicated than that, of course, in that if you just follow the sort of naive approach to building your Docker containers, you can end up with containers which are much larger and contain a lot more than you want in them. So there are a set of best practices, and I have the link here in terms of how to use those best practices to build your images in a multi-step stage to end up with a small image. At the simplest case, you're just running docker build-t test. But you're going to need to think about and understand that multi-stage build. I don't really have time to get into that, but I just wanted to make you aware that that is something you're going to need to think about and understand if you want to have good images. Finally, you're going to push that to the registry, and then you can run and test under Docker or Kubernetes from the image in the registry. In terms of deploying, so how do I now get that Docker image? I bundled my application into it with the Docker file. Now I want to deploy it so that I can actually run and test my application. So deploying it into Kubernetes ends up being, at least to start with, writing some YAML files. So you have to write some files that say, here's the image I want to use, here's how many copies that I want to run, and here's how I want to deployment. So at the very top on the right-hand side there, I have a deployment.yaml, which has basically a simple deployment that says use test1:new is my image name. I'm going to pull it locally, so I'm not pulling it from a registry. And I think I said I want 2 copies of that to run. So you have to start to learn how to write this YAML, what the sort of language is to be able to say, I want a deployment. Unfortunately, it's not quite that simple in that, OK, now you have some containers running. Now you have to have a way to tell people how to get to them. So they have something called a service. So you'll write a service YAML, which says, OK, here's how you connect and get to those pods, and it will load balance across the number of instances you have. That still doesn't let you get at your application from the outside world yet. You also need something called an ingress, which says, OK, I'm going to come from the internet, and I'm going to get you to your services, which will then get me to my pods. So you can end up writing quite a bit of YAML to get there. And so that's something, again, you're going to have to probably learn and understand. Luckily, there's something called Helm charts. Helm charts actually just bundle those files together into something which is more easily deployable. So having written a deployment, a service, and an ingress, Helm charts give you a very specific structure. You can run something called Helm init. It'll give you the structure that you see on the right. In the templates, they actually have templated implementation, so you can use the values to configure it to start your application. You can also do what I did for my simple example, was to just copy my existing deployment service and ingress files into the structure, and then you can easily deploy as opposed to having to like individually start the deployment, start the service, start the ingress. And Helm kind of bills itself as the package registry for Kubernetes. You can go there and say Helm init a particular service. Say you want to start Grafana, you can Helm init Grafana or Helm install Grafana. It'll pull down what you need, start it all up, and you've got Kubernetes running all these things. More recently, you've probably heard about, if you've been looking at Kubernetes, operators. Operators give you a more programmatic control than simply having some YAML that tells you how you want to put together your application. So many applications are, now come with operators, which are things you can write your own code to use the Kubernetes APIs to spin up pods, monitor the pods, and figure out what's going on. And again, just mention that as like, here's another thing that probably you're going to want to understand and know what's going on. So at this point, kind of step back and think about testing. So, we've said based on the 12 factors that we want to keep our development, staging, and production as close as possible. And in particular, if we're like developing on Mac OS or Windows, which a lot of our end workstations are, but we're going to deploy on Docker, which is basically Linux. It's important not to test in Windows or OS X and then deploy directly to Linux. So we actually want to test in Docker or in Kubernetes, ideally. But it just strikes me there's going to be a lot of overhead there in terms of I got to rebuild my Docker image. I've got to my Docker image. I got to start my Docker image. I got to start my testing. And do I really need to do that on every single cycle? That could be a lot of overhead. So I'll just leave you thinking about that as we'll come back to that later on. Now I'll get into a few of the services, the sort of qualities of service that you don't quite get for free in Kubernetes, but as a Node application developer, you can do a little bit of work and it will make your application a better fit for that cloud native development. The first two are liveness and readiness probes. So by adding an endpoint into your application, Kubernetes can automatically figure out from the information you're giving it, when should I restart your container. Something's gone wrong in the container, you're no longer responding. It will help you figure out when to restart that. And similarly, readiness lets it figure out when it can actually start sending you traffic. If you think of the case where I'm going to migrate from one version to another, you don't necessarily want to spin up your new versions and automatically instantly redirect your traffic, because they still be maybe connecting to the database, doing whatever work and initialization they need to do the first time. And if you start directing traffic to them right away, those transactions are going to wait and be slower. So you might as well continue to serve existing transactions until they're ready. And the readiness endpoint lets you tell Kubernetes when your application is ready to actually accept traffic. For liveness, there's 3 probe types. You can do basically a shell into the container and run some command. You can do an HTTP probe or a TCP probe. For Node.js, typically HTTP probe is the most common. You quite often already have an HTTP server running for your API or your web application. Basically, the probe considers that it's okay if you are greater than 200, less than 400. And the key thing is that you shouldn't just you could just say I'm going to point that at one of my existing endpoints, and if it responds, that's good enough. But really, you want to think about in your application, what should I be checking to make sure I'm really up? Not just that, hey, I'm going to respond to the login page or something, right? Let's see if I can check if the database is really up and other resources that are running. So you want to build a more complicated, I shouldn't say more complicated, but it's probably more than just a simple check. You want to think about what in your application you should check to say whether I'm really up or not. And on the side here, I just show again in the YAML that we talked about, I can easily add this liveness probe that says it's an HTTP probe. The path is the live endpoint on port 3000. And you can say, well, don't start checking until like 5 seconds after I spin up, and check every 10 seconds. Likely going to have a longer period than that, I don't know, a minute or whatever. And as I said, you should really check more than just that your web server's up. In terms of readiness, you get the same options and config as a liveness probe. But instead of restarting your pod for you automatically, it just holds off routing traffic. And if you've ever used Kubernetes to say, I'm going to start up a pod, you've probably seen something like this if you use the kubectl to get the status. And you can see here it says, 0 out of 1 are ready. And basically, if you have a readiness endpoint, until you respond positively, it'll stay like that in terms of it's not ready, I'm not going to route traffic to it. And again, on the right-hand side, I just show, I can have a liveness probe, I can have a readiness probe, same kind of configuration. You can make them the same endpoint if you want, and that's how you would add them in. As I mentioned, you probably want to do something that's more than just one check. So we do have a module on Cloud Native JS called Cloud Health, which lets you, it provides an infrastructure for registering things that you want to check. So you could write those independently and then register each of the things you want to check, and it aggregates the responses and says, okay, I'm going to tell you, I'm going to provide you an endpoint that says, yes, I'm live, not live, I'm ready, not ready. The next thing to think about is logging that may be a little bit different in the Kubernetes environment. So containers are ephemeral in that, the 12-factor approach is like, you're not going to have state in your container. Make sure you could kill them. They can go away at any time. So unlike other environments, you're not going to be writing your logs directly to the file system in most cases. You might be able to do that if you actually you can mount volumes into pods that are shared. But if you think about a large deployment across a whole bunch of nodes and a whole bunch of pods, you can think that's going to get pretty hard to manage in terms of keeping those shares across machines and nodes and everything. So generally, that's not what's done. You just end up logging to standard out. And you let the infrastructure handle that, which actually as a developer is a little bit nicer. You just need a simple logger, which will log to standard out. The trend seems to be to go towards structured logging, so log data being in JSON format. And here's an example that I put together using Pinot, which is a nice logger. And it's very, very simple to come up with your log at different levels. And from Kubernetes, you can actually say, okay, kubectl logs, get me the logs coming out of a particular pod. And then there's things like LogDNA and other tools that will, like in cloud environments, pull all this logging together and give you a view across all of the pods for your application. So the nice news on logging is maybe it's a little simpler than what you would have to worry about in other environments. The next thing is metrics. Again, you have a container. It's not as easy necessarily to get into the container to find, maybe you got 60, 100 containers running. So actually going into each container to get data about what's going on can be a challenge. So the next thing you want to think about is providing a metrics endpoint. Luckily, there's kind of a standard that's people are moving towards, which is Prometheus. And it defines a set of base metrics that you should provide. And there's some good clients, node clients that you can go and get, prom client at Metrics Prometheus, that will actually instrument and give you a metrics endpoint pretty easily. You should think about not just, you get the default metrics almost for free because those modules will extract them and give them for you. But the other thing is to think about what does your application do that for business reasons or SRE reasons you should be exposing. So think about what other metrics you can add. And again, the prom client provides a nice API for saying, here are my additional metrics, and then they'll end up in the data. In a Kubernetes environment, there's already tools that will help scrape those endpoints, collect all the data. And it took me an hour or two to get up through Helm installing Grafana and some stuff to get nice dashboards where I could create, graphs and gauges of all this kind of data. So as a node developer, if we do this little bit of work, it helps on the other side when people want to actually see what's going on. Then at this point, I think I just want to step back and think about, okay, we've talked about a bunch of things. What about upgrades? Because I find, at least in real life, the more successful you are, the longer you've had to support your product, the more and more upgrading becomes a big piece of your work. So what does that mean if I'm developing my Node.js application for a cloud-native environment? So Kubernetes actually does a great job of handling the updating, like migrating from one version to another in terms of like, I've already got my Docker images and I'm going to move from version 1 to version 2. And so don't really have to worry about that, but it doesn't provide anything about like, how do I upgrade my Docker containers? And so inside my containers, I have modules like Express. I have loggers, I have a whole bunch, probably a bunch of my own application code. And I probably have a number of applications, and maybe with microservices world, a bunch of microservices, and even a whole bunch of microservices for my one application. So actually figuring out what all versions I need to update if I want to move to a new version of Express, or there's a security vulnerability and we want to upgrade, can actually, the X times Y containers can end up being, I got a lot of containers to upgrade, and that's a lot of work. Which ones need to be upgraded? What versions do I have in each one? That becomes a lot to manage. And then I also imagine moving to another team. So, we've talked about these endpoints, we've talked about, building Docker files, writing YAML files, and there's not necessarily a standard or one way to do any of those things. So if you had to learn it once the first time, when you move to another team, it's quite possible you're now going to have to figure out how people have decided to do it in that particular instance. What endpoints do they using, which logger, how are we organizing our deployment artifacts? And I do think consistency through documentation can help, but I still see that as a challenge in terms of how do we make that work. So at this point, after learning all this stuff, I'm kind of at, what? Do I really need to learn and understand all of this stuff? Because really, I want to focus on the application code. That's the value I'm delivering to my company, not learning YAML, not learning how to deploy Kubernetes. Now, in a small company, maybe you're the one person doing everything, but in a lot of cases, you want to focus on your application, and having to figure out all this other stuff is just what? Is this really what's where we're going? So from my perspective, we want to figure out how to separate the concerns. There's some things that, as a developer, I want to very actively be involved in, and I want to change every time I make a new application. And then there's really a common stack below me that it's not going to make my application any better to choose something different. I think we need to get to the point where I've got this Docker image, and somehow I can build that efficiently and easily, and embed in it a common stack, so something that has the pieces that we've all agreed, the developers, the architects, the operators, because for your production application, probably everybody's involved in trying to make that a success. So we've all come together, we've agreed that that set makes sense to us. And then when I build my specific applications, I can just focus on my application code on top of that. Now, I do want to say, we want to have consistency where it makes sense, but not uniformity. So I'm not saying we're going to have one stack and we always use that one stack. We want to be consistent where it doesn't really matter to the particular implementation, but not be uniform. So if it really matters, let's push it into the part above the stack. Or in fact, we quite often would expect that we'll have multiple stacks for a particular organization because there's probably different contexts that make sense. So at this point, I'm okay, well, let's hope there's some tools. And the good news is that there's a few open source projects, and IBM is contributing to some of these projects that are aiming to try and address this particular challenge. The first one's called Appsody. What it does is it helps you build those Docker images in an efficient way. And what it does in the first part is to say, well, for my local development, I need to iterate very quickly, and I want to test in Docker, but I don't want to have to rebuild my Docker image every time, start up Docker to be able to test it. So what it does is it takes your application code, and it maps it into a Docker image, and then there's code to watch for changes. And so that when you're developing your application locally on your machine, it's mapped into a Docker container, so you're testing in Docker, but it can automatically pick up your changes, and you don't actually have to restart Docker itself. The other thing it does is it uses the stack model to say, we're going to have a number of stacks, and I'm going to take your application. So for example, Express, I'm going to take just your Express components and layer that into a stack or a Docker image that we can use to do that testing. Once you've gone through the rapid development cycle, you can then say build, which will then build you a Docker image. Again, the advantage being you don't have to understand multi-stage Docker builds and all the best practices because it's going to be bundled into the stack for your organization. And then you can even test it in Kubernetes just by saying Appsody deploy. So again, without having to know all that YAML and stuff, you can get it up and running and be accessible. Of course, we've thought about Node.js, and so there's a number of stacks that are available, pre-made stacks. There's Node.js, Node.js Express, Node.js loopback. And the functions one I'm not going to talk about, but we do have a talk in the same room following this, where Chris Bailey is going to get into a lot more detail of if you want to do serverless type programming, how can you do that using Appsody and some of the benefits and so forth. So stick around if you want to know a little bit more about that. At this point, I just want to drop down to a very quick demo. If I can get out of the show. So I don't have a ton of time, but I just want to show you how easy it is. So the first thing I'm doing is just saying, I want to use the Node.js Express stack, which is going to bring me in the standard Docker image with Express already installed. And, OK, sorry. OK, it doesn't matter what it's called. So we're just going to create that project. And you can see what I end up with is this app.js. And if I look at that, this is just my very simplest Express application that says hello world. Now, since I don't have a lot of time, I'm not going to go into the particular steps. But I'm now going to say Appsody deploy. And if you see everything that's going by, you'll see a lot of the components that I talked about in that it's using Docker to do a two-stage, multi-stage build to efficiently build you a Docker image. It's then going to basically push that container to the right place and then create all the YAML that you need to deploy the application through Kubernetes. So if I say get all, we can see that I actually now have, and I could have shown you this before, I guess I didn't, but I now have a fully deployed application which is running. If I go to the endpoint, and I go there, actually, and I do need to look back at my terminal to see 3155. Oops. OK, 31. No, that wasn't it. Sorry. I need the port of the. OK, sorry. What was it again? 30882? Yeah, OK. So I get my hello from Appsody. So that was my application. But because the stack includes support for liveness, I automatically get a liveness endpoint, which is responding for me. I get a readiness endpoint, and I get a metrics endpoint. So basically, by using that stack, a lot of those things that I talked about us needing to worry about Node.js developers, we've actually built that into the base stack, and you don't have to worry about it when you're doing your individual application itself. So let me just switch back here. So that's Appsody. The next thing I just want to mention, another open source project is codewind. This brings a nice UI on top of Appsody, as well as some other things like integration with Tecton pipelines, some performance monitoring. It's a bring your own UI, so you can use Visual Code Studio or bring your own editor. You can use Visual Code Studio. Kind of provides that next layer if you like to work with user interfaces as opposed to the command line. Cabanero is another open source project. And again, what it does is it bundles together the different pieces along with some curated stacks. So we talked about stacks that you would want to potentially put in for your organization. This gives you some curated stacks, which we expect you would start with and then sort of customize for your use. And I'll just end up with, like, if you're interested, I don't have time to go into the details, but of course there is the talk, which is immediately following this one. You can also come and see us at the IBM booth. We have some quick labs, one of which includes getting involved and hands-on with Appsody. You can, of course, come talk to us. We have a nice online lab, 75 minutes. So if you really want to dive down into a little bit more details of using the different tools, you can go through that lab. And then, of course, you can also go to Cloud Native JS for a little bit more information on some of those components, like the health checking module. So at this point, thank you very much for coming. And I'm not sure. I think we're right on time. So that's probably the end.